Okay, and under this assumption, we have, first of all, a nice interpretation as electronic circuits. So we can think of each edge in the federated learning network as a resistor that is connected to junctions that are under a certain potential. So the local model parameters are like electronic potentials that drive a current through the resistors. And this current, the value of this current is given by the product of the edge weight and the difference between the local model parameters. So this difference between local model parameters is like a potential difference or voltage that drives a current, an abstract current through a resistor. And then those of you who also had the privilege, like me, to learn about circuit theory a long time ago in electrical engineering program, there is something called Kirchhoff's laws. So there is something called the conservation of current. So whatever current that flows into a node here must be compensated by a current that is generated by a loss function. So these loss functions, or the gradients of the loss function, they are in some sense generators that push currents, that drive currents into the circuit. Yeah, I find this a very nice interpretation because of my background of electrical engineering before I rebranded myself as a machine learning expert. So why is this cool? Does anyone have an idea? I mean, you could, I mean, I don't know how practical this is, but you could solve GTV minimization by building an electric circuit with real resistors and voltage sources, and then measure the potentials at each of these junctions. And these potentials are the solutions of GTV minimization. There are, of course, some obstacles here, like how do you implement vector valued potentials, but maybe we can get around this. So one way to solve optimization problems is to embody the problem as a physical system, like a resistor network with voltages, and then let the magic happen, so to say. Let the physical process swing in when you attach the voltage source, and at some point you will have here a steady current and steady potentials. And these are the solutions of GTV minimization.